Today is May 21st, 2022. It is a Saturday, and it is also day 307 of data science. And today I'm going to basically do what I did in day 305, which is I had some data, I plotted the distribution of that data, and I just made it look pretty. So it ended up looking like this. The only thing different is that in day 305, I made my own data. But over here today in day 307, I'm going to use a real life data set from Kaggle, so the London weather data. The link to the data set is right here. It's the first thing, and then just download it. And then in order to upload it to Google Collaboratory, you want to go to Files, this icon over here, and then just select the file and then click Open, and then right click once it pops up, right here, and then copy the path. And then in order to read it into Python, you want to use Pandas, which is a data analytical library that helps you work with data. And you want to import it as PD because you don't want to be doing pandas dot every time you want to use a pandas function, because it's like too long. Instead we do PD dot. So I'm going to set my data equal to a variable called data, which is really self-explanatory. So I'm going to do then PD dot read CSV to use the read CSV function from pandas. And the reason we're doing read CSV is because this file here is called the London weather .csv, so it's comma separated value file. Now in order to look at the data, I'm going to use the function head, which basically prints out the first 5 rows of the data set, but I want 2 rows of the data set. And then here's the data. Now the essence of what I'm trying to do here is I'm going to try to plot the distributions, or a histogram, right, of some columns of this data. So in order to do that, I'm going to import Seaborn as SNS and Matplotlib.pyplot as PLT, which these are basically data visualization libraries. And then I'm going to use the hisplot function from Seaborn. And in order to plot a distribution of one of these columns, let's say I want to plot the distribution of the minimum temperatures of London, then I would do data, because that's where my data's in. I set it equal to data. And then I'll just do, it should pop up here, and I'll just do min temp, right, to use bracket notation, and I run it, and it's going to give me the histogram, or the distribution of the minimum temperatures in London. And then I'll show you 2 more. So I'll do, I think there is a mean temperature, and there is also a maximum temperature. Oops, what happened? So there is a mean temperature, and there is also a maximum temperature in London in that year. I think the year is what? I think most of the dates say 1979. So these are the distributions, and so the goal is basically to have these distributions in one graph. In one figure. So the way we do that is you do plt.subplot. So subplots is a function that takes in, well, I like to just use 3 parameters, so the number of rows, 1, number of columns, let's do 3, because I want to plot those 3 distributions, or those 3 graphs, in one figure. And then the figure size, I want it to, it goes by x and y, or by width and height, so I want to do like maybe 12 and then 4. And then what that's going to return is your figure, and then it's going to return 3 axes. So axes are basically the graphs that you see here. The figure is where the graphs are placed, which is in the white box. So to kind of show you how to set this up, so this is what it returns, right? So the order that it returns it to you is the order that you want to set the variables as. So I'm going to do equal, right? And so because the figure is returned first, I'm going to set my figure variable to something like fig. You can set it equal to whatever you want, like figure, fig, whatever, box. And then for the axes, which are your graphs, which are on your figure, I like to just do graph 1, graph 2, and graph 3. Now, as for the syntax, the reason we have parentheses, well, the outside parentheses is just pure syntax, but in those parentheses, we have basically more parentheses. So each pair of parentheses represents a row. So if I had another row, I could do like graph 4. And so what would happen is that this would be one row. So whatever is in these parentheses is in one row, and then this would be another row. So that's how you would set a variable a variable to a graph that's not in the same row. So let's say you had 2 rows, then it would be like that. So each row would be represented by a pair of parentheses separated by columns. But because we have 1 row, we're just only going to have 1 pair of parentheses. And in that pair of parentheses, we're going to have our 3 graphs, which are right next to each other. Now, if you run that, it's just going to return to you the figure and the graphs, and you already have the all of those set to a variable. And now, because of that, we can control it. Now, to give you an idea of basically what the figure is, I'm going to set the face color of the figure to something like blue. And you'll see that the figure is basically the background, right? And then the graphs are basically what's on the figure. So I really heard this is a good example. Like, you can think of the figure as your canvas. When you're a painter, you have a canvas, and whatever you paint on that canvas are your axes, right? So these are your axes. That's why when you go to plt.subplots and you just run that, it returns to you and it says axes. And what they mean by axes is they mean these 3 graphs over here, and I like to call them graph 1, graph 2, graph 3, but a lot of people just do AX and then AX1, AX2. But yeah, so the figure is the blue box, and then the axes or the subplots or the graphs are what's on the figure. So there's these 3 axes, these 3 graphs, these 3 subplots, whatever you like to call it. There's a lot of terminology for them. Okay, but I'm gonna remove this real quick. And essentially the goal again is to plot these 3 histograms over here. So the way to do that is I'll do SNS. I'll actually, you know what? We can simply just take the code that we used, just plot it in here. Paste it in there and do the same thing over here. And the thing is, if you run that, it's going to look a little weird. It's literally just going to plot it all in one. But we want to localize. We want to position where each of these histograms are going to go. So I have 3 axes, right? So luckily, or 3 graphs, luckily I set them all to their own respective variables. So, and also lucky for us, Seaborn has a parameter called ax, which is basically asking us, okay, what graph do you want us to plot this in? And I say, okay, I want the minimum temperature to be plotted in graph 1. So if I run that, now the distribution of the minimum temperature is going to be plotted in graph 1. And you'll wait 1 second because it's loading. Okay, now you see that, right? And then you can do the same thing for the second one. So I want the second one to be plotted in graph 2, and I want the maximum temperature distribution to be plotted in graph 3. Run that. And then you'll see that they're each plotted in their own respective spaces. So now let's say that for some odd reason you use Matplotlib to plot the graph. So you were like, you wanted to basically plot data, let's say min temp. Let me actually put this in another line. Let's say this is how you did it instead of using Seaborn. It's a weird thing to do. I mean, that's not really how you plot a history. Let's see. Can you do like a... Let me do this real quick. I don't think it has like a histogram. Does it have a hist? Yeah, it does. Okay. So let's say for some odd reason you wanted to plot the histogram like this. I mean, you could. I guess you could, but whatever. And then you wanted to like put it in a figure. Now, and then you're like, okay, well, you know, it must have I'll just do AX is equal to, let's say graph 1. Well, if you run this, it's actually going to give you an error because PLT does not have an AX parameter. Only Seaborn does. And so the way you do this, hold on, if I were to put this over here, let me show you. It's so slow. Okay, this is taking its time. I'll just upload it, I mean unpause when it's done. Alright, so I basically had to make a new thing because this is just frozen. It's not working. So again, if you run it, it's going to give you an error. It says got multiple values for argument x. But, oh, here's the thing. Okay, so let's pretend there's not that. Okay, still. So, problem is here is it says that you got multiple values for argument ax, but the thing is, well, it should tell you that there shouldn't be an ax because there is no ax. I don't know why it's not. Usually, if you do this, there we go. Well, no, it's supposed to say an error, another error. I mean, yeah, it's still an error, but it's not the error that I want. Okay, let me do this. Ready? So let me copy this and go here. It should tell me if data is null, data. N. Well, it's still like it's still not working as it should. Like it's still not plotting. Wait, what happened? Okay, yeah. It's still not plotting graph 1 because not only, well, either, okay, hold on. Let me run this. Either way, it still doesn't plot graph 1 because plt.hist, anything that's plt dot whatever graph, there is no parameter ax. Like it doesn't give you ax. So it shouldn't even work. Yeah. So in order to fix that problem, if you want to use the hist function, that specific function, you're just gonna have to directly graph like graph1 dot hist, and then that should work. So yeah, but it's gonna look different. Oops, why do I have a comma here? Let's delete that. It's gonna look different because it's a different histogram function. Here we're using Seaborn's, here we're using Matplotlib's histogram function. Okay, anyway, that was just that little caveat there. Where? Yeah, it's right there. Okay, run it how it should be. So, now that we have our data plotted, that was pretty much it. Now let's go to the customizing. So, let's see. I want to make this a little bit, let's do 5. But let's do like 15.5. Maybe that'll work. 15.4. That looks much better. Okay, so maybe we can make it look more better if we do fig tight layout, and that's gonna kind of even out the space. There we go. So basically we're taking the figure, which is this the big box where everything is in, and we're using the function tight layout, which kind of just evens out the figure and everything in it. It evens out the spacing of the figure. So again, to kind of see where everything is, I'm going to give it a nice color. Let me go to colors. Do I want to use this one? It's a hex code, so we'll do that. Okay, so essentially what I did was I took the figure and patch, don't even ask me because I have to do research on that. It's interesting because why don't we just do fig.setColor? Why do we have to use patch? Does it work without? So I'm assuming it does not. Yeah, it doesn't. Figure object has no attribute set color, but it does have an attribute patch. Let's do some research on that. So patch and figure. Excuse me. Heck no. Python. Let's look at the documentation. So Matplotlib Patches.patch. A patch is a 2D artist with the face color and an edge color. Are you kidding? As if it's a person. A patch is a 2D artist. If any of edge color, face color, line width, or blah blah blah, they default to the RC params settings. What is RC params? I've always heard that word. Okay, the following KWARG properties are supported with patch. Isolated patches do not have to transform. But why do we need it? The library also provides a function called patch, which replaces the real objects in your code with mock instances. You can use patch as either a decorator, interesting, so that's interesting because we are using it as a decorator, or a context manager, giving you control over the scope in which the object will be mocked. What does it mean, replaces the real objects in your code with mock instances? So I'm assuming, I love how it's referring to object and instances, so it's giving class vibes, like when you make a class and you do objects and instances, mock instances. So the real objects it replaces with instances. So when you call an instance, you replaces it with instances, and you kind of, oh, well yeah, you change the things inside. Okay, I'm just thinking out loud. No, not Matplotlib. Matplotlib, how to add. What are patches in Python? How to label a patch. Does nobody do anything about this? Python, Matplotlib Patches. Object-oriented programming, plotting, Piazza. What did I do? Oh wow, that's very nice. Oh, that's really beautiful actually, a whole HTML file. That's really cool. This notebook will help you gain better, oh wow, they made an HTML notebook. And they download it as an HTML. That's really pretty. Okay, object-oriented programming, blah, blah, blah. How to draw stuff using Matplotlib. Everything in Python is an object, yes. Matplotlib is a primary plotting library of Python, and it is no exception from the object-oriented nature of Python. Everything you see in Matplotlib plot is an object. One particularly interesting object is Matplotlib.patches. We will now discuss this class before. See, I knew it. It has to do with the class. We will now discuss this class before we use it in our work. Matplotlib.patches is a collection of classes, okay, that make objects that can be drawn as patches. What are patches? What do you mean can be drawn as patches? Oh my god. On an axis. These include circles, polygons, rectangles, etc. There is a base called Matplotlib.patches, patch from which all of these other classes, blah blah blah, are derived. The Matplotlib blah 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 is self-derived from Matplotlib.artist. There are a number of classes, blah blah blah. Display one is a figure. Yes, a figure can have one or more axes on it, which can display stuff in them. Interestingly enough, axes and figures too in Matplotlib are also objects which can draw any object of the class Matplotlib blah 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 blah, which itself is derived blah 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 blah. The base of blah 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 blah. Okay, you can learn more blah 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 blah. An artist is added to an axis object in a figure using axes blah blah blah. Okay. What use of objects and classes do you see here? How can OOP, object-oriented programming, reduce the amount of code and the complexity of the code? I don't know, man. What is this, college? Can you identify why this particular hierarchy will be... No, I can't. Can you just explain to me? I just don't understand how... What does it do? What does it do? Note that Matplotlib axes is different from Matplotlib.axis, which is actually a subclass of blah 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 blah. Yeah, I know. Maybe I should pronounce it differently, like axes, axis, whatever. It's still complicated. It's still confusing. Like, why would they name it like this? Why can't they just say Matplotlib.graph? Like, why couldn't they have done that, huh? Anyway, To complicate the naming further, yeah, there's a function of matplotlib.pyplot called axis, which is used to set the limits of matplotlib.axis. Yeah, blah blah blah. Okay, next. Yeah, but I don't understand why. I love that there's an assignment. Like, this is so nice. I love this. But still, like, can someone explain? Like, okay, my polygon. What? So you can import shapes from patches. But then, oh, so I'm assuming that essentially patches is used to draw, but because it's a Matplotlib function, it can also be used in figures. And so it could be that set face color can be used to set the face color of a polygon. But instead, if we wanted, we could actually also use it to set the face color of our figure. Interesting. So it's not like patches is solely made for the purpose of figures. It's actually made to draw shapes, but it happens to be that we can use those same functions to customize our figures as well. I think that's what I'm getting from this. So I guess if we were to do like my polygon.patches not patches, but I think it's patch, isn't it patch? Where am I? Okay, dot polygon patch set color to the polygon, and it would do the same thing. Let me see if it works. Let me go to deep notes, run this, missing parentheses. Okay, another version of Python. Alright, so if I run this, okay, so if I wanted to change, let's do my polygon dot patch dot set face color or color. It doesn't work. Okay, so what if I do set, because it's okay, so if I import, oops, wrong thing, over here, import matplotlib.pyplot as plt, is because I think instead of doing my polygon, I should do plt.patch set face color. Dot patch or plt dot patch dot set face color, because it's, how do you in the world, okay, so I guess it's not working like this, but I just want to know if color is the same thing as face color in figure, like how the syntax is different. So like in a figure you would do patch dot set face color, but then here there's a parameter called color because this polygon is created. It's interesting. Oh, because the function is the polygon, which contains parameters of a patch. Interesting. Okay, anyway. Just a little research there. So apparently Patch is basically a 2D artist, apparently. And you can just use the functions from Patch to decorate your figure. Okay, great. Now, let's say I want to make this a little bit prettier. Maybe I would want to do I want to use another color? Okay, I'll use that color, and then what I'll do is, or maybe I want to use a darker color, but not something, maybe this. Run that. Okay, that's ugly. Okay, so, we'll stay with that color. Now let's say I kind of want the graphs to be, I want to get rid of, let's start with the color of the subplots themselves, or the graphs. So I'll do graph 1 dot, is it the same thing, patch dot set color, or is it just set color? Because now it's the graph. I think I'll do patch dot set color. I don't remember how I did this. And I'll just do, can I do none or do I do the same color? What if I do none? Would that give me an error? Whoa. E3 D FFF. Okay, so I guess that works. So I guess we can't do none. Are you sure we can't do none? What if I do none in here? Okay, so we would have to put it in quotations. Okay, so it's the same thing, patch.setColor. Alright then. Okay, and we'll do the same thing for graph 2. Patch.setColor to none. And then do the same thing for this graph over here. I feel like this is too repetitive, so can I do a function that takes in, okay, how about I'll make a function called change graph color. I'll take in the color, and then maybe I'll do, okay, so I'll take graph 1. Well, it depends on how many graphs you have. Graph 1 dot patch dot set color to color. If I pass it as a string, would it actually? I don't think it would, because then it would just be, and it would return graph. But it's not gonna return. I don't think this is gonna work. Whoops. I don't think it's supposed to actually return. How do I return multiple things? But it's not going to return graph 1. I'm just going to do that. Return. No, it's actually not going to do that. I mean, it did work though, but it didn't. Yeah, I don't think this works like this. Let me just delete that. Anyway, I'm just gonna leave it like this, because it just, I don't like the fact that I have to repeat it 3 times. It reminds me of CSS. Like, if you just give something a class, you could just be like, okay, dot graphs, and then set whatever property and value you want to it, and you don't have to repeat it 5,000 times. Okay, but anyway. Okay, so that's one thing, and then I want to get rid of the spines. So the spines are basically the lines that make up the graph, like the border. So do graph 1 dot spines. And then I want the top one gone. Can I set it? I don't think. What's the format for this? So for the spines, we select it, right? Oh, I'm in the wrong one. 305. For the spines, and then you set color. Oh, so you don't just remove it, you set the color. Now I'm looking at my old code. Literally. Because I was just, on day 305, I just pretty much copied and pasted. I just wanted to get it done to like get an idea of what I can do. But today I'm trying to learn actually. So graph 1 dot spines, and then we locate the spine that we want, which is the top one, and then we're gonna set the color to none. And it should remove it. Now let's say, so why is it set color here and not patch dot set color? So would it be bad if I did patch dot set color? Would that work? Spine has no attribute patch. Interesting. So why does the figure not have an attribute set color, but spine, the figure doesn't have set color. So patch, set color comes from patch. So we need to, but figure has patch. But then spines doesn't have patch, but it has set color. But does set color come from patch or what? Like what? So if that's the case, why do we need patch? That didn't work the last time, did it? Exactly. So why does figure have patch but spines don't? So why does spines in Matplotlib don't have Patches, or what? Where are we even getting set color from? Whatever. It's just a question I had. Where are we? Did I delete my thing? Oh, it's right here. Oh my god, I got scared. Okay. So it's interesting to me that we can use set color for spines, but we can't do set color for figure, and we have to actually use patch.setColor. So why does it work? Why does this work and then this doesn't work? Like what? That doesn't make sense. All right. So run that. Right. And then I want to do the same thing for the right. Is there any way I could just do like comma right? Would that work? Let's be crazy and try to figure it out. No, I wish it did work. Would have been so much easier instead of having to repeat myself 5,000 times. Okay. And then let's do this same thing for graph 2 and graph 3. So graph 2, graph 2, graph 3, graph 3. Now we have something looking like that. And then let's see, what else could we do to make this pretty? We can go to the bars themselves. So in Seaborn, we could set the color equal to something complementary. So I'll go back to colors. Wait, what happened? Okay, over here, and I'll go to shading, and I'll do something like, ooh, I like this blue. Let me see if this looks pretty. If not, then we'll change it. Where am I? Okay. Set that equal to that. It's hex code, so I'll do that. No, I want more purple, so let me do something like that. Okay, and then I'll do the same thing for the rest of the bars. For the rest of the graphs. Okay, and then I kind of want there to be less. You know what? It would have been nicer. Actually, no. Oh my god, I actually want to do a normal distribution. Okay, focus. Okay, we'll do this first and then we'll go back. So, I want to give each graph a title. So I'll go back to here and I'll just do graph 1.setTitle, and I'll do distribution of minimum temperatures in London. Hopefully I spelled that right. Temperature, I don't even know, man. Okay, and then do the same thing for graph 2, graph 3, oops, graph 2, and then distribution. Are you kidding? Minimum. This is mean temperatures in London, and this is maximum. Maximum. Jesus. Okay, really quickly, I kind of want to look at just the column of the date. Is it, oh my god, all the way until 2020? Oh my god, what? Oh my god, it has 15,340 dates. That is crazy. So, yeah, so I was just going to say in London in 1979 because I thought they were all 1979, but apparently it reaches until 2020, so I think that's really good. That's super cool. So I'll just leave it as London instead of specifying a year. So if I run that, it should put a thing there. What do you call it? A title, right? Okay, now it looks a little off. I don't like it. So what I'll do is, how I've done this before, but I forgot to add some padding between the title and the graph. So let me go back to the first day that I started reviewing these. Are these it? No, it's the first day that I started doing, oh, come on. The first day I started plotting figures, which is this over here. So I'm pretty sure it's supposed to be somewhere. It's the one where I have a lot of cells over here. This one. It was day 134. Okay, so let me go back to day 134. I think it's data science day. Oh my god, I almost closed my thing. I would have cried. So let me go all the way back up to day 1 to 200 and try to find day 134 because I think I have it there. Alright, 134. Oh, this article, I still remember, I think I dream about this article. It's the best article. It like made me understand the difference between axes and what do you call it, figure. Okay, hold on. Somewhere here. I had it somewhere here. Oh yeah, this is another way we can plot. Where is it? Oh my god, this graph was crazy to plot. Oh, over here, pad. Oh, there we go. Okay. So set title, you just set it to pad.25, but I know that it's different in something else. It's like a different thing. Okay, so where's my set title? I don't see it. Okay, right here. So you just do pad to add some padding. Just add that in there. Run that. It should give me some padding between the title and the graph. Only thing is I want it to be, actually it's fine, it doesn't really matter. Maybe I should do like, is there a font size? Font size, yeah. So font size 10, but it's already small. Oh, I know what I wanted to do. I didn't like that it was so long. So instead of changing the font size, I'll just add a space in between. So distribution of mean temperatures, and then in London, I'll add space or an enter so that it enters and it goes to a new line. See? Pretty. All right. And then I'll change the, so it should do frequency, like the X and Y label. So the X should stay. The Y labels, should I make it as frequency instead of count? Frequency? I think I should. All right, so over here, I'll do X label and set it equal to min temperature, and then I'll do the same here and here, and here I'll do mean temperature, and then here I'll do max temperature, and then I'll do Y label, and I'll set it to frequency, and then do the same over here and over here. Alright, object has no property X label. Really? You don't? Oh, it's because of bar graphs do. Alright, so it's okay. Let me then get rid of all this and then just do it manually, I guess. So I'll do graph1 dot set X label, and I'll set it to minimum temperature on that day, And then I'll just do the same to graph 2, graph 3, and do mean temperatures. I'll do average temperature. And I'll do maximum temperature. And then I'll do the same for these. Whoops. And I'll just do Y label, Y label, Y label. And I'll change it to frequency. Whoa, 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 whoa. So just change that to frequency. Close that out, remove that, make this nice and pretty. Am I missing something? I don't think so. Run it and it should work. Alright, and then I think that's good. Distribution of minimum temperatures in London. Maybe we do want to change the font size to something bigger. So let me see what 20 looks like. What do you mean? Oh, are these only attributes for bar plots? That's crazy. I guess that's fine. Whatever then. Alright, and then I think that's it. I think that's what I want to do. Is there anything else? I think that's how I'm gonna leave these distributions, but now I want to plot the normal, like the normal curve of this, which is, I'm really excited. Okay, so what I'll do is I'll import, I don't think we need lens space. Do we need lens space? Yes, we do. NumPy as NP. Import, so from SciPy, import stats. Oh. And then, actually, I don't think I need, I don't need NumPy. I just need the stats function to plot the normal distribution. So, essentially, I'm going to plot my x values. I'm going to have my y values. So my x values is just going to be data, are going to be my minimum temperature. Are you kidding? And then my y values is going to be stats.norm.pdf, so it's going to be the probability density function of all of my x values, given certain mean, which is loc, and then the scale, which is the standard deviation, is going to be standard deviation. We actually have to set these equal to values, so mean and then standard deviation. So we get this by doing data, min temp, and there's a mean function, so that's going to set the mean of that column of that data, the minimum temperature. So the average minimum temperature is going to be the mean. And then the standard deviation is a little bit, it's the same, except you have to take something into account. So we have to determine if this is population data or if it is a sample data. Standard deviation. So this data is real data that is counting, basically, it's just data from each day. So it's not like you're taking a random sample of days and you're getting, well, actually, it could be a random sample of all temperatures in London, because we haven't had all temperatures of London, but they're not random samples. They're not random. It's not like it's a sample, it's population data. So because of that, we don't want to do n-1. Sorry, I'm thinking out loud. I'll explain this in 1 second. So n-1 is when we want to do, when we have a sample, but because this is population, it should be n-0, and currently standard deviation automatically in Python is n-1, right? We'll see how this works. So if I just do this real quick and I print out the standard deviation, does it change when the DDOF is equal to 1? Right, so automatically it's 1, so I need the DDOF equal to 0 because it's a population. So I'll do DDOF equal to 0. Okay, so here's the thing. So standard deviation is basically how each data point deviates from the mean, right? So in this case, for the minimum temperature, we're calculating how each minimum temperature in London deviates from the average minimum temperature in London. So the way you calculate this depends on whether this is sample data or population data. Now, this is basically data from each day in London. You're not collecting a random sample of dates and then, this is not random samples. This is all in order. It's just a population data. Like, this is raw data from the population. This is not like you selected randomly a few dates and you took that data. No, this is all of the data. It's the population data. So because of that, we don't need, in the standard deviation formula, in the bottom of the standard deviation formula, we have to do n-1, which is the sample size minus 1. But because we didn't collect a sample size, we don't have to do n-1, and it just becomes capital N, well, whatever, it just becomes n. So the reason we do -1 if we collect data from a sample and try to find standard deviation from a sample is because we want to account for any bias, so any like faults that could happen, any mistakes, we want to account for that. So that's why we do -1. But because this is population data, there's no need to do that. So, and usually -1, not usually, -1 is called the degree of freedom. So that's why we have DDOF, so degree of freedom. I don't know what the first D stands for. Do I want to Google it? No, not really. So yeah, but degree of freedom, so we want to set it equal to 0 because we don't want to subtract anything from it. Because this is population data. Python has the DOF set to 1 automatically, but if you use NumPy's standard deviation function, NumPy actually has the degree of freedom set to 0 automatically. Just a little tip there, because I've researched, I was like, why is NumPy and just regular pandas giving me regular Python giving me 2 different answers for standard deviation? I was like, why is this? And turns out they have different degrees of freedom. All right, so now that we have that set, we want to do SNS dot hist plot, and we want to plot the x value. Actually, no, we want to do plt dot plot, and we want to do x values and y values. You can't do a histogram with 2 columns. It's only 1 column because the histogram plots the frequency of each data value of 1 column. So when we're plotting, we're basically passing an x and a y, and when we run that, it should give us, wow, that's crazy. That is actually insane. Whoa. Is that really what it is? Stats.norm.pdf. Wow. That's insane. But why does it plot each? Why is there multiple graphs? Interesting. Not graphs, I mean curves. I mean, it is normal at the end of the day, but why is there multiples? What if I did one space and then the size? Let me try and see. So code. Is that how it's supposed to look like? All right. Okay, so what if I imported NumPy as NP? And instead of taking those x values straight from there, I would have done np.1 space. And to give it a start, it would be mean minus 3 times standard deviation, and then it would be the mean plus 3 times the standard deviation where we would stop. And then the size, I would say, okay, 1,000 values in between. There we go. So what's the difference? Like, why did it give me, why did it do that? Interesting. I mean, it is the normal, because Okay, so I set the data to be the min temperature. Wait, so let me comment this out real quick and try something real quick. So if I take data min temperature and I take the minimum value, which is negative 11.8, so instead of doing that, I'll do negative 11.8, and then I were to take the maximum value, 22.3, that's what it should. Interesting. If I did 5, it would become more jagged. Yeah. If I did 1,000, it would become more normally distributed. So then what's the difference? Why did it do this? Why did it plot so many curves? I told it to take those x values and find the probability density function for each of those x values, with the log being the mean and the scale being the standard deviation. Is it because they want me to set the start and the end point? Interesting. Well, anyway, this is the graph that I want. And let me delete this. It's interesting that it wanted me to use lens space. Right, well, this is the normal distribution for that. Now, okay, let's give it a name. So let's do plt.title. Normal distribution, normal distribution of minimum temperatures. In London, and then that. Okay, and then give it some, hopefully this works here, padding. Alright, so that's what that looks like. Let's do that for the next 2 graphs. So I'm just gonna copy the code. Whoa, 2 times. Can we reset, please? Okay, and for this one, I'll do mean temperature for the mean one, and I'll do normal distribution of average temperatures in London, and then here I'll do max temperature, and here I'll do normal distribution of maximum temperatures in London, and then plot that. It should look like that. I mean, all normally distributed graphs are going to look the same. It's just the axes that are different, but in this case, it's not. So, let's see. And then to plot them all in one figure, we'll do plt.subplots, and rows 1 and calls 3, fig size probably 15.5 for, I don't know, for run that. That's gonna give me figure and axes, so I'll do fig, and then I'll do graph 1, graph 2, graph 3, set that equal to whatever it returns, and then I'll set the fig dot patch set, set face color to a certain hex color, which I think was E something. Do I still have it? No. So I'll have to go back up here and get that color. And then, let's see. So we'll do that. Let me put it over here so we can actually see it. And then to put those graphs in there, Just gonna go and copy the code. So I'll copy this code over here. Actually copy everything and then just put it in here. And then I'll do, let's see, I'll do plt.plot. So again, instead of plt.plot, we want to do graph1.plot because that's how you do it, because you can't do plt.plot and then set, okay, axes equal to graph1 like you would do in Seaborn. That doesn't work because, oh, actually, maybe it'll work this time. Maybe it'll actually show you the correct error. Here we go. Here's the correct error. Line 2D object has no property ax, right? So it doesn't have a property ax, so we can't do that. So we just do graph1.plot instead. Run that, and it should plot it in your first graph. And then we'll do graph1 dot set title instead of title, because that's what it comes with. That. What if I did title only? Because it's a Matplotlib property. Yeah. So you do set title. Okay, and then you would do the same thing for the other ones. So I'm going to copy this over here, the second one. So I'll do second graph. And then I'll do graph2 instead of plt.plot, and then here I'll do graph2, and it should show up in graph2. Distribution, oops, forgot the set title. Run that, it should also work. And then finally this one over here, distribution, normal distribution, okay, and then be over here, graph3, and then over here is graph3 set title, and it should pop up there. And then to kind of go over everything, we'll do graph 1 dot set color to none. Oops. Face color. Ugh, the day that I'll learn how to spell. Okay, so it should be transparent now. We'll do the same thing for graph 2 and graph 3. Okay, and then we'll change the actual color to be the same color as this thing over here. Where even is it? His plot over here. I'll just take this. I don't think this would have I don't think, does it have an attribute color? Or maybe it's something different. It does have an attribute color. Okay. What if I changed it to white? Would that look better? Ooh, no, it doesn't look better. What if I change it to black? Oops. Well, that's not how you spell black. Okay. It does look better, but I like the color that I had. Whoa. Okay, so we'll do the same over here and over here. And then I'll run it by pressing Control Enter. Are you kidding? Control Enter. Are you serious? What do you mean? Control Enter. Thank you. Alright. So that's what we have so far. I do want to make it a little nicer and more evened out, so I'm going to do fig tight layout. Run that, and it should be a little nicer here. Okay, good. Now, let's say I want to plot both these normal distributions and the actual distributions in one same figure. So the way I'll do that, let's do plotting 6 graphs, I guess, or putting it all together. Oh my god, the day. Literally, I can never spell. Alright, so I'll go up here and just copy all of this code. Go back down here. Put that in there. And then instead of doing... So remember how I told you that if... Okay, let's think about this. One figure, right? We have 6 graphs, meaning I want everything to be evened out. So I'll want 2 rows now, and I'll leave the same number of columns. But because I have 2 rows, I have to specify the rows over here. So I'll do comma and put another pair of parentheses, and then put row let's say 4. Row 4, I meant graph 4. Graph 5, and graph 6. Okay, and so now that's going to return to us a figure with 6 graphs. Okay, now in order to input, input, I'm just going to select this and then just pop it in there, and then I'll just change it to their respective names. So instead of graph 1, this is graph 4, graph 5, graph 5, this is graph 6, run that, and they should be put in there. Okay, and now to kind of make it better. So here is the problem. See, when I was explaining this 2 days ago, I was like showing, I was trying to explain what tight layout does, and this wouldn't happen. Like after I called the function tight layout, like this wouldn't happen again. But this is a perfect example. Let me actually screenshot, because literally, actually I don't have to screenshot, I could just save it. Tight layout problem. Okay, are you kidding me? Okay, so here's the thing. You can clearly see that it's overlapping. So when you go all the way up here, or you can go anywhere, actually, I'll just go to the bottom so you can see real quick. If I do fig tight layout, because it's a tight layout, you want to run that function and it should basically even out the spacing for you. Now, you can see that now it's not overlapping each other, but it still looks weird. So you want to go to your fig size over here and maybe make it way larger than that. So I'll do maybe 10 for the height and see if that makes any difference. Okay, and maybe make it a little larger. So we'll do 20 for the width. Okay, and here's our beautiful, beautiful graphs. And now you can kind of see that the font size now is a little small. So the way I can fix that is by using the font size function. Okay, but here's the thing. You can usually do that if you have bar plots like in the same line, but since this is just plot and it's also like his plots, I don't think it's an attribute. So to Google we go. So how to change font size, are you kidding? Font size of histogram label. Title, not label. Python. Not RC params. Ugh, that's so irritating. Change font size in Matplotlib. Seaborn. Oh, don't you tell me. Font scale. Okay, so we'll do sns.set. Why can't we just do set font scale instead of set and then put parenthesis font scale? Font scale 2. Okay, then I guess we'll do that. So sns.set. What? Is it set and then font scale? Oh, great. When did I even indent it? Pretty sure. Did I read wrong? Set font scale. Oh yeah, underscore. Whoa, okay, how about 15? Why did I say 2? Oh, okay. No, let's do 8. Oh my god, what is going on? 2? What is with Seaborn? This is what I mean. This is the problem. Like, once you set something, it doesn't go back to how it was. Like, kid you not? Like, what the heck? Okay, let me go here. Can we just please? Ugh, why does this do this to me? Why is it like that? No, I don't want. Are you kidding? Are you actually kidding? This is horrible. What if... You know what? Instead of doing that for everything, I'll just go individually to here. Well, it's not those things I'm worried about. It was the title, which are where? I can't even find it. Okay, it's right here. So graph set title, and then font size 8, and do the same thing here and here, and run that. Oh my god, why is this so ugly? Literally, this is so ugly. Like, actually so ugly. So, yeah, this didn't work out. So font size 8 for the normal distributions. So that's so small. So how about we do 15, 15, and 15. Okay, that's better. See? See? Jesus Christ. And then for the titles here, we'll do font size 15 as well. So apparently we just can't do it in when we call the plot itself, but these are attributes of like the titles, etc. Do I like the way it looks? No. So let's fix that. So let's also do the X labels. Hopefully it's an attribute here. Font size 15. Oops. Font size. And I don't think I set that up for the normal distribution ones. This looks so bad, but it's fine. Oh my god, when did the white lines come in? What the heck? This is a mess. Let's see. Even the skin, oh my god, even the numbers of the axes are so big. Can I just do, oh my god, can I just do SNS dot X, no, SNS dot X tick, tick, tick labels and set the font size. Or maybe it's just tick labels. Why? What do you mean? So rude. Change X tick labels font size. Matplotlib. plt.xtext x oh it's one word, okay. Where am I? Tick labels. Are you kidding me? Did I spell it wrong? X tick labels font size. Tick label. I'm so sure that I did not spell that wrong. SNS. Next tick label font size 15. What do you mean? So what if I do graph 1.x tick labels? What do you mean? What do you mean? I wanna say yes, I wanna say no. This is so exhausting. Oh, it's because I didn't do set. Oh. Are you kidding me? I'm done. This is over. It's over. What do you mean? Oh, I have to actually do the label? No, I can't do that. X values. Oh my god, I give up, bro. Okay, we're not doing this. What if I just put this down a bit? So I'll do instead of, let's just do 10. Let's just do 5. Oh my god, this is so bad. I'm gonna cry. Alright, so let me just copy all this. Put this here and just change the font size anywhere I see font size. Oh my god, I give up. What is this? Why can't it just be normal? Please tell me that there's something that automatically does this. How to make Seaborn figure automatically proportional? Proportional. No. Visually proportional. Okay. Pretty question mark. This is what I mean. Yeah, no, this is not what I mean. I wanted like actual like multiple graphs. I mean, I could totally fix it. It's just I don't want to. Like, it's gonna be so tedious, and I don't have the time. Like, I want to be done with this right now. Like, all I have to do is change the font size, and then change the X and Y ticks, and I just don't have time for this. I'm just gonna leave it. I literally kid you not. Do I care enough? Do I really care enough? I mean, this is as good as it's gonna get. They're so big though. Did I just delete it? Oh my god, I got so scared. I didn't even add a thing. Oh my god, I can't. So over here I'll do graph 4, graph 4, 5, graph 5, graph 6, graph 6, and then change graph 4. And instead I'll do, instead of minimum temperature, for the X label I'll just, actually yeah, that's exactly what I'm gonna do. And then just do density. And then I'll change this to density, 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 and then this would be, wait, what did I do? to average. Okay, so what did I do now? Graph 6, graph 4, 4, 5, 5, 6, 6, density, minimum, average, maximum. So why is it not there? Set. Oh, I have 3. What the? Oh, so is it the same here too? It's supposed to be X. Oh no, it is supposed to be Y. I'm so confused. Whoops, wrong one. Wrong one. Supposed to be Y. But like, why is it not showing up? For graph 6, the X label's not showing up. Graph 5. Oh, because it's supposed to be 5. And then 6. And then this is supposed to be 4, 5, and then 6. Okay, great. Alright, I guess that's fine. Let me look at one more thing. So tight. So SNS dot, not SNS, fig dot tight layout. Documentation. I just need to look at the parameters in it. Overlapping. Tight layout, but what are the parameters in it? Oh, beautiful. This is what I wanted. So the height of the padding, the width of the padding. You can see. Interesting. Oh wow, that's beautiful. Oh my, you're kidding me. This is CSS, bro. There's this property. Oh, that's funny. I'm not even gonna get into it. Okay, let's see. So this is what I wanted here, to kind of control this a little bit better. So instead of padding, okay, let me see what that looks like. So can I do padding of 1, the width of the padding and the height of the padding? That doesn't change anything. 0.4, the width of the padding. Well, I wanted the height to be changed because I needed to be more space. The height of the padding needed to be double. There we go, that's better. Now how do I give a margin? I'm gonna save this because I actually used the source. Hold on, where am I? Oh, right there, duh. Okay. How to add a margin to figure in Matplotlib. Oh, whatever. Set margins, set the title of the plot, set margins of the plot using margins, blah blah blah. pyplot.margins. So can I do plt.margins or fig.margin? Interesting. Okay, let's just try it out. So here I'll do, let me see if fig.margins, or I would assume it would be set margins. I don't think that's a thing. Let me do margins first and see if that works, and I'll do like 4 or 5, put in whatever random numbers there are. See if that works. No. So how about the plt.margins would work? Or plt.pyplot? What PLT I imported it. Yeah, but that's not going to do anything. So, is it fig dot set margins? Well, that's not helping out here. Tight layout guide. Python samples of Matplotlib, blah, blah, blah. Oh my god. Oh my god, okay. How to, what the heck? Can this thing, why can't it just give me an answer? I just want an answer. Ooh. Are you kidding me right now? What in the world is this? Cause your element here. But I don't want to zero it out. I want to add a margin. Can someone just answer my question? I had to set the margins of that Matplotlib figure. Ugh, not this thing again. One space. PLT dot margins, but that doesn't work. And fig margins doesn't work either. PLT dot margins. What if I do? Ah, what the heck? Okay, obviously this doesn't work, so we're gonna leave it as it is. And I don't think I need this here. Okay, we're gonna leave it as it is because, yeah, we'll get into the hard things some other day. But, yeah, this is what it looks like. I mean, all normal distributions look the same because that's, well, it's in the name. They're normal, so normal means that they look the same. Like, it's normal. Anyway, it's just the axes that are sometimes different. What else is there to it? So, I mean, even in the histograms, you see the more data there is, the more you can see that it's normal, kind of, it follows the curve. Let's see what else. Yeah, so pretty much the point of the normal distribution is to find the proportion of, let's say I wanted to find the proportion of minimum temperatures in London that were below 0 degrees. Well, then I could do that by using its normal distribution. But we'll get to that another day. Yeah, actually, should I get to it now? Honestly, maybe I should. Okay, I'll just try it out. I'll try it out. So let's say, okay, norm dot stats dot cdf, and I do, okay, norm dot stats dot cdf. From SciPy import norm, and then norm stats.cdf. I want the value, so I said below 0, and then the mean and the standard deviation. Whoops, actually. The loc is data min temp dot mean, and the scale, which is the standard deviation, is data max temp dot, whoops, did I do max? I meant min temp dot st, what the heck, std with dd degree of freedom, so ddof equal to 0 because it's automatically equal to 1, and run that, and it should give us, actually let's round it, so I'll do round it to 4 decimal places. from SciPy import norm. Norm cannot import name norm from SciPy. What do you mean? Is this a NumPy thing? Norm stats dot norm from SciPy import stats. Name norm is not defined. Am I going crazy? Stats dot norm. Why did I do norm dot stats? Okay, there we go. That's the proportion of minimum temperatures that were below 0 degrees. Wow, that's beautiful. Which is basically what, 7%, 7.7%, 7.8% of temperatures, of minimum temperatures were below. Well, that doesn't make sense because they're already minimum temperatures. It would make more sense if it was like just a average list of temperatures. Yeah, so that's the proportion of that. So essentially, should I get my tablet out? I think I should. Let me get it out. Okay, I'll kind of show you what we just found visually. So I'll show you real quick. Let me go to my whiteboard. Why is my thing not working? Is it broken? Does it need a battery change? My tablet, it's not working. Oh my god, stop it. It's not working. Oh, I plugged in the wrong thing. I was like, why is it not working? So scared there for a second. I was like, okay, there we go. So I'm going to, what in the world happened? Okay, my whiteboard. Let me make a new one. And then while I make a new one, I'll really quickly just plot SNS.hist. Actually, I already did do that. Hold on. I plotted the one for minimum temperatures, distribution of minimum temperatures. Yeah, I did. So I'll just save this image and I'll call it min temp. And I'll go to my whiteboard and I'll upload that image here so we can get a look at what we're doing here. Images. Where? Oh, I should be more organized. Here we go. And then I'll just lock it. All right, so basically the question was, let me get my thing. So the question was, whoa, why does it look so, okay. So what proportion of minimum temperatures, whoops, cannot even write. What proportion of minimum temperatures were below 0 degrees Fahrenheit? No, London is Celsius, right? Whatever, just 0 degrees. So that's the question we're trying to answer. And so essentially what we did was we looked at 0 degrees and we're just trying to find the area. Like, this tells you the proportion of minimum temperatures that were below 0. And so in order to do that, in Python, use the CDF function, which you get from stats. So you import from SciPy, import stats, and then from stats you can use the norm function, which is norm, like, you know, your normal CDF that you would use in a calculator, and you would do norm CDF, and then you would put in the value, the x value that you want to find the area below or above it. In this case, we wanted to find the area below 0, so x would equal to 0. And then we would have to basically plug in the mean, which is it's set as loc, so that's your mean. And so what I did, I just took the mean from what's it called? From the column by literally saying, getting the mean from it. So I did data min temp, and I then did dot mean, and then that got me the mean, and then the scale is the same thing. It's data min temp dot std, and then whoops, and then there, and then if you run that, right, it would give you 0. What was it, 777, oh, it was 0.079 7779, I think it was that, right? That's what it was. Or was it? Let me see. Go all the way down. 0.07. What was it again? 0.27s, right? Okay, yeah. So that was a proportion. So basically, this P right here. What the heck is going on? I can't even see my mouse. What's going on right now? Don't know what's going on. So the proportion. Why is it like this? I'm trying to see. I can't see. I can't see my mouse. Are you kidding? Are you like actually kidding me right now? I'm trying to see my mouse and I can't see it, so isn't that amazing? Okay, 1 second. I'm trying to figure this out. So if I were to just, if I do this, still can't see it. Okay, let me just go home and then open it back up again. And I still can't see it. Great, so I'm gonna have to write blindly. So it's not where it is, not where it is. Okay, so this is 0.0779. So over here, this is the area over here. All right, so that is the proportion of minimum temperatures that were below 0 degrees. And that's the use of a normal distribution. Oh, you know what I should have done? I should have labeled what it was. I'll do that in 1 second. So yeah, that's what we just found. If you want to do this on your calculator instead of with Python, you would just do, I literally kid you not, I cannot right now because this thing doesn't want to work. I can't see it. I don't even think I'm going to show you how to do it with the calculator because I can't see the mouse. I'm literally so annoyed. Okay, so what the heck is going on? My computer is literally going crazy. It's been acting insane these days. It's like it doesn't like me. Okay, I'm literally so lost right now. Okay, you know what? I'm just gonna tell you. I'm not gonna write it down because apparently this thing doesn't want me to write it down. So essentially, If you want to do it on your TI-83, you just go to stats, no, vars, second vars, second vars, second stats, second vars, second vars, and then you go to 2. So, ow, I'm literally such a mess right now. Okay, you go to second vars, and then you go to click on 2, and that's going to be your normal CDF function, and then it's going to ask you for nothing, literally. You're just going to have to know what to put in. So it's your lower bound, upper bound, and your mean and your standard deviation. So your lower bound would be where you want to start, which would be negative infinity, but there is no negative infinity in your what do you call it, in your calculator, so you're gonna have to put in a big number to replace that, so it would be like -1e99. And then your upper bound would be your x point, that in this case, right, that you want to figure out. It's basically where you want to end up bound, so it would be 0, and then your mean would be whatever your mean is when you find it, and then your standard deviation whatever your standard deviation is when you find it. But in this case, I just got my mean and standard deviation from I'm trying to take a screenshot of this from Python. And what else? Oh, and if you do, and then you click enter, and it should give you your value. And then if you do have a TI-84, you do the same thing. You go to second vars, and then click on 2, and then it actually at least tells you what you're trying to find. So it gives you an option of lower, upper, and then sigma, and then mu, and then sigma, and then you just plug in the values, same thing, and then run it. It should give you the same thing. But this is if we're just trying to find the area or the proportion of whatever below a certain point. If we're trying to find actually above a certain point in Python, you would have to do 1 minus whatever you get for your CDF. So you would just do 1 minus this number, and that would be it. If it was above 0 degrees, in your calculator, you don't have to do that, because you're putting the interval in which you want the area to be found, and you're saying your lower point and your upper point. So you don't have to do that, because generally, your CDF function calculates the area under a curve, which is why you do that here. But if you're trying to calculate the area above the curve, I'll actually do that too. Might as well, you know what I mean? I might as well. Today is a Saturday anyway, I have time. So if you want to calculate above a curve, you want to do literally 1 minus that. That's it. So that's the area above the curve. Right? Above the curve. Did I just say above the curve? I mean above 0. So what is the proportion of minimum temperatures that were above 0 degrees? Well, you do 1 minus that, and you get that. Another way you can do this is if you were to just do stats.norm.sf, which SF is basically 1 minus CDF. So you don't literally have to write 1 minus. It just, if you do SF, it does it for you. And then you just plug in the same values. So I'll just take that in. I'll actually take this in here and then put them there. And then if you round it to 4 decimal places, it should give you the same answer. There we go. So it's the same thing as doing 1 minus CDF. Yeah, so that's basically, let me draw, hopefully I'll see the pen now. Or maybe not, man, I don't know. I can't even see my mouse. Oh, there we go. Images. Go to quick axes. I just said quick axes instead of access. That's funny. I'm like saturated with Matplotlib. I'm like axes, quick axes. Okay, anyway, well, we just found, hopefully I can see the pen now. And there we go again. I can't see it. Oh, I can. Yay. Okay. So, I'm at 0, right? So I'm trying to find, the question is, what proportion of minimum temperatures, that's so ugly, temperatures are or were above 0 degrees. So you take in your 0, and basically you want to find this area right, whoa, I'll just use my highlighter at this point. So you want to find this area right here, which, are you kidding me? My computer is going crazy. This area, which is essentially, the proportion of all temperatures, minimum temperatures that were above 0, right? Because they're above 0, they're on the right to 0. That's the area that you're trying to find. So how do you do this? Well, in Python, again, you just do 1 minus CDF man, or just do SF and just put the same values that you did in up here. For your TI-83, you would use second in your calculator, right? Second vars, and then click on 2, and it's just going to give you something looking like this, and then you're going to have to put in your values in there. So again, it would be your x value, so in this case it would be 0. Actually it would, well, the format is lower bound, upper bound, mu, then sigma. So mu is mean, and sigma is your standard deviation. And essentially what we do here is you do normal CDF. Your lower bound would be 0, your upper bound would be 1E99, which represents infinity. Your mean is whatever your mean is. So actually, let's figure it out. Let's figure out what our mean is. So if I go to data min temp, and I'll do dot mean, that's our mean. Our mean is pretty much 8. So I'm just going to round it to 4 decimal places. Actually, I wouldn't round. If I were to put this in my calculator, I would just put it in as it is, because that's what it is, man. I'm not, yeah, that's pretty much it. And then I'll just do the same thing for the standard deviation. And make my degree of freedom, what was it again, 0? Yeah. And then that's my standard deviation. So what did we get? Let me go back. So I would put in, for my mean, I would put in 7.5598 and so on, finish the number. And then my standard deviation would be 53265, and then so on, finish the number. And then when you press enter, you're going to get your value of 0.9221. Okay, and that is the proportion of minimum temperatures that were above 0. Now, to do this in a TI-84, it's the same location, second bars, and then press 2. And in this time, it's actually going to give you the following. So it's going to give you like lower, upper, and then it's going to show you sigma, and then a standard deviation, and then it's going to have a paste option that when you hover over it, it turns black. Well, we'll get to that in a second. So lower, again, is your 0. Because that's where you're starting. So think of it as like an interval of where you're trying to find the area of. So 0, upper would be what, like 1E99. Your sigma is 7.5598, so on, and your standard deviation is 5.3265, and so on. And then you hover over this, it turns black, and just click enter, and it should give you the same thing. It should give you 0.9221, and that's how you get that on your TI-84. So again, the lower bound and upper bound, you can think of it as an interval. You know how in math class they ask you, okay, from what's the domain of this, right? So the domain would be the interval of where your graph starts and ends at the x-axis. So it starts off, let's say, like -3, and it ends at, let's say, 3, right? So this interval over here, this would be your lower bound, this -3. And your upper bound, your upper bound would be this 3 right here. So this is the area you're trying to find, that interval. So the same thing, if we have an area that we're trying to find, and we start at 0 and we want to find above, the area above it, the interval, the lower bound would be 0, and then since it's a normal distribution and it continues on to infinity, then we use 1e99 to represent our upper bound. So that's the interval you're trying to calculate the area of. So that's the concept right there. And then, is there anything else? No. So that's why you don't have to do 1 minus whatever you get, because it's literally, you're telling it where to calculate the interval from. So you're telling it, okay, I want it from 0 to here, not from 0 to the left. So that's why you don't have to do 1 minus whatever in your calculator. But in Python, CDF just calculates your interval from the bottom or from the left of it. It doesn't do anything above or to the right, so of whatever point you want. So in this case, it would only calculate the proportion of whatever below 0, like whatever my x point is, which is 0 in this case. That's why you would have to do 1 minus, or you can just simply do the SF function, which does 1 minus whatever you get automatically. Let's see, anything else that I wanted to mention? So essentially, this area right here is equal to 0.9221. Anything else? I mean, and if you were to add these numbers, it would give you 1, right? Let's see. I think that's it. Anyway, that's it for today. That's the use of, these things. Again, same thing for TI-83 and TI-84 for the one above. Just put in. The mean is the same, the standard deviation the same. It's just that, actually, yeah, it's just the lower bound and upper bound that are different. So maybe I should add that too. So, whoops. So for the TI-83 over here, it would just be normal CDF, since we're trying to find the interval over here is negative E199 all the way to 0. So that would be my interval. So I would just be like, okay, negative E199, which represents negative infinity, to 0. So that would be my my lower bound to upper bound. And then the same thing, it would be the same, just continue it, and the same, so this is be the same mu, and then the same sigma, so 5.3265. And then for the TI-84, it would be mu sigma. Lower would be negative 1E99, upper would be 0, this would be 5598, continue the number, 5.3265, continue the number, and press enter, and it should give you 0.0779, and then when you press enter over here, it should give you 0.0779. also. So yeah, that's a little summary, different ways to do it, because Jesus Christ, because it's great to have different ways to do it. Anyway, yeah, so that's it, right? I think that's it. Let me just, can I save this as an image? I'll just copy the link to this and then just put it in there. Is there anything else? Where did my thing go? Oh, okay. So what was this, day 307? What the 307? Can't even. I'm telling you the day that I could write. Okay, how do I know I can save this as an image, so how do I do it? Oh, right there. Am I blind? High resolution, please. Actually, no, yeah, high resolution. Tell me it's not zoomed out. Oh, it's fine. Okay. So I'll just save as, and I'll save it as that, I guess. Close this. Go back to my Chrome, and then just put this one over here. Copy this, get out of here, go back to here and do Control Z 5,000 times. Really? Control Z doesn't work? Oh, there we go. Alright, so that's it for today. Let me go back to Chrome. And just paste that image in there. So that's it for these ones over here. This I should just, whoa. Actually, I'll leave it there, I don't care. This is just an overall image, so let me put that above. And then let me make a section called using normal distributions. Oh, and then I forgot, I wanted to do something else. So for the thingy, I wanted to say width, and then, where's my post-it note? Oh my god, when am I gonna be done with this? It's almost midnight. Oh my god, I haven't eaten. This is so bad. Okay, mu. Oh, what? I don't know the mu. So I guess I'm gonna have to do plus, string data. I know the mu, but I do. Well, now, you know what? Whatever. Okay, min temp, and then I'll round that to 4 decimal places. Okay, and then I'll do plus sigma. Where's my post-it note? Sigma. And that would be string round for data min temp, and then let's see what that looks like. Hopefully it works. Where did it even go? What now? Argument 2 must be string, but I did make it a string. Are you blind? String. I literally said string. Oh. Whoops. That doesn't make sense. Oh, because I had 2. Okay. Are you kidding? What do you mean invalid syntax? Oh, this sucks. Okay. String dot, so round, we round, right? And then inside we don't need this. So we have the string on the outside, and then the round function over here. Same thing over here. So we have the string on the outside, and then we have the data function over here. So that should work now. Are you kidding me right now? Are you kidding? Literally, what even is this? What is this? Distribution of minimum temperatures in London. I mean, it did work, but but no. Dot mean. Oh, I'm so dumb. I forgot to do the mean, and then I forgot to do the standard deviation. I'm like, that's the whole point I'm doing this. Okay, DDOF is equal to 0. Okay, run that. Now what? Oh, for the love of God. What do you mean flow is not callable? I literally changed you into a... Oh. Oh, Jesus Christ, right. If you could ever just be slow. Dot. Okay, there we go, finally. So, oh, and we also need a space. Oh my God. Okay, run that. Okay, now it basically, okay, so we have the distribution of minimum temperatures in London. No! Oh my God, I meant to put this in the normal distribution. Literally, what is going on with me? Like, actually. Okay, delete all that. And then do this. Whoops, not that, comma. I meant to do this in the title of the normal distributions, if I could actually find them. Okay, over here. So over here, this happens. What now? We don't need this padding here. We don't need this. Don't need that, don't need that. Don't need this. Do we have? Did I do an extra parenthesis? Are you kidding me right now? Oh, Jesus Christ. Oh, so we did need, oh my God, literally get out. Are you kidding me? Okay. I'm going, I don't even know where to put it. I'm going crazy. I don't even know where I am right now. Standard deviation, right? And then you end that, I think it ends with 2 parentheses, so it would go actually here. Right? And then you would put a comma. And hopefully that works. Possibly not. Possibly yes, possibly not. Oh my God. Is this for graph 2? Oh no, I meant to do that for graph 1. Oh my God, this is going crazy. So this one is actually mean temp. This one, oh, I should have done mean temp. That's for graph 2. And then for graph, what in the world? I mean, not graph 2, graph 5. So 3, 4, 5, right? And so then this one is supposed to be the min temp, and then min temp, and then should work like that. So now what's happening is basically it's telling me the standard deviation and the sigma of each normal distribution. So standard deviation and the mean. Okay. And then finally, let's do this for the last one. and then just change it to maximum temperature to get the maximum mean temperature and the maximum standard deviation of the mean temperature. Not the maximum mean temperature, like the mean, you know what, whatever. I'm trying to find the mean. Isn't that weird? I'm trying to find the average mean temperature. Anyway, yeah, this is what I wanted to do. The visualization could use a little work, you know, it could be bigger, like everything could be proportional, you know, but that's a story for another day. But yeah, I think I did a pretty good job. What do you think? I'm really proud of this work. It's so pretty, like it's so beautiful. I think I'm gonna cry. Only thing is, like, the grids, man, what? Yeah, that's what I'm saying, like the visualizations need a little job, you know what I mean? And usually my handwriting is prettier, so yeah, sorry about that one. So yeah, that's what that is. Okay, now I just realized I should move all of this code. Let me copy all of this to my actual data science. Okay, let me get rid of this. Go all the way down. So delete. Wait. Until what point did I copy? Oh yeah. Alright, I don't even know at this point. I think I copied up until here, so let me go delete this and then just paste all of that in there. So wait, okay, that's good. Okay, I'm supposed to delete this line. Are you kidding me right now? Thank you. Delete this, delete this. Alright. Okay, yeah, this is perfect. Nice. Okay, so this was a lot today. Pretty proud of this day. This day deserves a star because there's a lot of content in this and it's all correct. Must be nice. Once in a year. Once in a lifetime. Okay, and then what else? Only thing that's like off is the visualizations, but whatever, it's okay. So let me also save this as day 307 because I love day 307. Alright, let me do Control S to save everything. Okay, get out of there. Pretty sure I saved this link already. Hopefully I did. Whoops, wrong thing, wrong thing. Where am I going? Where am I going? Where am I? Okay, over here. Okay, well, yeah, that's it for today. Yeah, okay, bye now.